Paper 21, M1, question number 5. A small bead of mass 0.2 kg is attached to the end of a P of a light rod PQ. The bead is threaded onto a fixed vertical rough wire. Okay. The bead is held in equilibrium with the rod PQ inclined to the wire at an angle alpha, where tan of alpha equals to 4/3 as shown in figure 2. The thrust in the rod is T newtons. The bead is modeled as particle. Find the magnitude and the direction of the friction force acting on the bead when T is equal to 2.5. This is for 3 marks. The coefficient of friction between the bead and the wire is mu. Given that the greatest possible, this is for the second part, is 6.125, find the value. So coming to part A. For the part A, we have a situation in which there is a rod PQ and the thrust in the rod PQ is 2.5. So it's holding this piece, so the thrust is here, T newtons. The 0.2 is the mass. So the weight is 0.2 g newtons. The bead is modeled as particle. Find the magnitude and the direction of the frictional force. What you can do for this, tension is given, tension is 2.5. For the first part, tension is 2.5. What you can do, you can find the component of the horizontal and the vertical component of this force. Starting from the tail, first move here towards left and then vertically upwards 2 point. So these are the two components. Like this. 2.5 sine of alpha here and 2.5 cos of alpha here. So it means the upward force is 2.5 cos of alpha. From this information, you can complete a triangle, and tan of alpha we know is 4/3. So you can find by Pythagoras theorem the hypotenuse, and so tan of alpha in the question can be is 4/5, and cos of alpha if in the question can be used as 3/5. So 2.5 cos of alpha is 3/5. So 2.5 multiplied by 3/5 is 1.5. 1.5 newtons is the force which is acting in the upward direction in this whole setup. 1.5 newtons. So 1.5 newtons. So 1.5 newton is here and the other is 0.2 g. So out of 0.2 g and 2.5, which one is greater? Obviously 0.2 multiplied by 9.8 is 1.96. So from this basic working, 1.96, this is 1.96. So from here you can apply common sense that if the downward force is 1.96 and 1.5 is the force here which is acting in the upper direction, but it is in equilibrium. So there is a force, frictional force, acting where? Acting in the upward direction. So 1.5 plus friction can balance 1.96. So friction is here. So this is how you can make the direction for the friction. So friction is acting in the upward direction, very basic working. You find the component of the thrust in the upward direction, that is 1.5 newtons, and the weight is 1.96. As 1.96 is greater than 1.5, so there is some other agent which is helping 1.5, and that is the friction force acting in the upward direction. So F plus 1.5 is equals to 1.96. So here I can say that question is find the magnitude and the direction of the friction force for the A part. What I can do, so the direction is upwards. So direction is upward and the magnitude is simply upward forces equal to downward forces. Upward is F newtons and F upward is 1.5. Both arrows are in the upward directions, and the downward is 0.2 g. So F plus 1.5. So F plus 1.5 is this force, plus 1.5 is equals to 0.2 g. 0.2 g. So when you simplify, F is equal to 0.2 g minus 1.5. So 0.2 multiplied by 9.8 minus 1.5 is 0.46 newtons. So this is the friction force, 0.46 newtons. So question was find the friction force. So friction force is magnitude, hence I can write the magnitude of friction force is 0.46 newtons acting upwards. First part. B part is find the, given that the greatest possible value of t is 6.125. Greatest possible. For the greatest possible means that this p, the small b t is b is on the point of moving up the wire. So greatest. So what I can do for this part, I can change here the force of 2.5 now is 6.125. Now it is 6.125. So now thrust is 6.125 newtons, and obviously these two values will be different now. So these two values are different. So I'm going to erase this. Working was for part A. Here what I can do is 6.125 sine of alpha here, 6.125 cos of alpha here, simple. And here you'll have to make this understanding that for the greatest, the friction force will act here down. And if this is the friction force, this rod is pushing this bead towards left, so the normal contact force is here. This is the normal contact force or normal reaction. Normal contact force, or simply this is called the normal reaction, is acting rightwards. So friction is, so for the greatest possible value of T, which is 6.125, the frictional force or the friction force will act downwards. And I can write a statement over here. for the greatest value of t, which is 6.125, the beat is on the point of moving or sliding up the wire. Hence, the friction force will act, the friction force will act in downward direction. So because the friction force always acts in the direction opposite to the direction of motion or opposite to the direction in which the object or the body tends to move. So this bead is on the point of moving up, so the friction force will act down, so it's clear from this figure. So friction is downwards and the weight is the same, 0.2 g, so the force is different, so 6.125 sine of alpha and 6.125 cos of alpha. So question is find the value of mu. So write it as equilibrium again because this is on the point of moving. Then greatest possible means on the point of moving. So rightward force is equal to leftward and upward equal to the downward. So rightward is R. You can see the right arrow towards right and the arrow of R towards right and 6.125 sine of alpha towards left. So R is equal to 6.125 sine of alpha. So horizontally. So I resolve the forces horizontally and vertically. I can write over here resolving forces horizontally and vertically. So for as equilibrium, this is a state of equilibrium. So rightward is R is equal to 6.125 sine of alpha and 6.125 sine of alpha and sine of alpha is 4 over 5 is 4 over 5. So R is equals to 6.125 multiplied by 4 over 5. So R has the value 6.125 multiplied by 4 over 5. So this is 4.9 newtons. And vertically, what is happening? So closely observe, the arrows in the upward direction are only 6.125 cos of alpha. F is acting downward direction, 0.2 g downward. So upward equals to the downward, 6.125 cos of alpha, 6.125 cos of alpha is equals to 0.2 g, which is the weight, plus F, plus F. And next, I can use the value of cos of alpha. Cos of alpha is 3 over 5 is equals to 0.2 g plus f. I can simplify and I can get the answer for this 6.125 multiplied by 0.6. So the left hand side is 3.675 is equals to 0.2 g plus f and minus 0.2 into 9.8. So 1 point, so this 1.715. So this calculation will give F is equals to 3.675 minus 0.2 G. So F is equals to 1.715 newtons. So you have the value of, we got the value of uh, R and the value of F using the formula for the friction, that friction is equals to mu R. So friction is 1.715, mu is question mark, and R has the value 4.9, 4.9. So mu is equals to 1.715 over 4.9, the answer. So you can verify this answer 1.17, 1.1715, sorry, 1.715 divided by 4.9 is 0.35. So mu is 0.35, the coefficient of friction in this case.